Hello, everyone. Welcome to the next session of our Cloud Native Launchpad series. If you missed any of the previous sessions, you can find the recordings on the Devon and Beyond Cloud Native page. And while you're there, please spend a moment to review the other series and webinars that we have added there for you. Our topic today is building and deploying serverless apps with Oracle Cloud Functions, where Functions is a serverless compute service that lets developers create, run, and scale applications without managing any infrastructure. In this session, we'll explore the capabilities of Functions and API Gateway with demos around deploying apps the serverless way. My name is Renu Bhatt, Program Lead for the Customer Enablement team here at Oracle, and our presenters for today are Eli Schilling and Olivia Fueda. And with that, please enjoy the session. Eli, take it forward.
Awesome. Thanks, Renu. Appreciate it. As Renu mentioned, this is our build and deploy serverless apps on OCI, part 5 of our Day 1 and Beyond Cloud Native Launchpad series. My name is Eli Schilling, developer advocate here at Oracle, and I'm joined by my colleague Olivia on the cloud engineering team. Olivia, you want to give a quick intro?
Hi, everyone. I'm a cloud engineer on the customer enablement team, and I look forward to today's session.
Fantastic. All right, so you are here today. This is our 5th session in the series, the serverless apps with OCI Functions. Hopefully, folks have been enjoying the series along the way here, and we look forward to also having you back for the 6th and final session next month, where we're going to get into the final boss battle with CI/CD architectures and OCI DevOps. All right, we're going to cover today a couple of really fun topics. So starting first with kind of the use cases and the key tenets behind serverless applications. What are they? Why are they so cool? We'll talk about OCI Functions as a platform for building and deploying your serverless applications. We'll then look at the API management capabilities that will allow you to expose your functions to end users and other application endpoints. And we're going to do some demos along the way. And of course, if there's any questions, please use the Q&A. Drop those questions out there for us, and we will do our best to respond as quickly as possible. So with that, I guess start with the question: why go serverless? One of the key tenets in app development over the years has really been about producing stable code, stable applications. We try to design in a way that we can handle exceptions, we can address faults, and ultimately minimize the blast radius, to put it lightly, so that if there is an issue, if an application component is impacted, if there's an issue with some code that we've deployed, we impact as little of our application environment as possible. And one of the best ways to accomplish that is to go serverless, where we're going to start to take kind of the larger application components, deconstruct those, and create more granular, more fine-grained application elements. Some of the key tenets that we want to focus on here, really, it is granular. So in terms of consuming resources, in terms of billing, we're literally operating at the millisecond level. So if we have a piece of code, if we have an application component that is processing something small, something quickly, maybe it takes 150, 200 milliseconds, and that's all we're having to focus on. We're not having to provision resources. We're not having to pay for, having a server or a whole fleet of servers up and running. We're only really paying for any time that code executes. This gives us a great amount of resiliency. So if we're executing this code hundreds or thousands of times in parallel, those are basically running synchronously. Because it is a smaller subset of code, it functions or it behaves, executes quickly, and we minimize the potential for impact if there's a problem. These are distributed, so think about at cloud scale being able to trigger from other services, from other applications, and be able to execute these in a serverless ecosystem across an entire cloud region. And one of the best parts outside of applications themselves is serverless components can be event driven. So if you think about orchestrating and operating our cloud ecosystem, serverless applications can be used to operate various things like log collection and aggregation and event alarming, and other integration activities beyond simply serving up an end user application. So very multi-purpose, very versatile as well. But what about the servers? Well, kind of like the notion of cloud, it is still someone else's servers. But again, you're not having to provision infrastructure, manage resources. It is simply a click, deploy the code, run the code, and it's all hands off from there. So you don't have to worry about any underlying infrastructure, patching, security. It's all baked in to the serverless ecosystem. All right, now I mentioned, the typical approach for beginning to build serverless applications. Typically, we're going to take, a monolith or even maybe a microservices application that we've started to deconstruct, and we're going to focus on small sections of code that are sort of iterative, where we can extrapolate that functionality, convert it into a very small, fine-grained serverless application, and begin to deploy those in at a larger scale. So we're moving that functionality out of the larger application construct and then putting it into our serverless ecosystem, where we can simply trigger that code to run, produce a response, and execute as many times as is prompted by the core application functionality. If we kind of pivot the conversation a little bit to OCI, this brings us into what we like to talk about as our flexible runtime strategy. And we talked about Kubernetes previously. You're probably familiar with the core concept of bare metal and virtual machines in the cloud. This is kind of the next layer up in terms of agility, where we're running serverless functions, and again, there's no underlying infrastructure. Gives us full control to simply write code, execute code, and deliver application functionality and resiliency to our customers, our users. All right. So with that, let's kind of peel back the layers of the onion and talk about OCI Functions a little bit. Functions, it's essentially a managed service. So it's integrated into our cloud ecosystem, like a lot of the other services we've talked about, allowing you to not only apply fine-grained access control with identity and access management, but also trigger functions or communicate with other services from inside that ecosystem. This is based on open standards for container native. The Open Container Initiative as well is basically baked into this. It's all built on open source, and it is secure in the cloud ecosystem. I already mentioned it's pay per use, and essentially it's auto scaling. So as many times as fast as you need to trigger your functions, simply initiate the trigger or call the function, and the system automatically scales out, scales in to handle the appropriate resource requirements. Looking at the Q&A really quick. So we'll get into deploying functions. It does require a container build capability. So whether that's Docker or Podman or something similar, you would utilize a requisite tool to build your container image that's going to be running your function. Let's see, can OCI Functions be executed from Integration Cloud, Oracle Integration Cloud? Do we have an adapter, or it publishes URL that needs to be invoked? Yeah, we can talk about that a little bit more later, but basically with API Gateway, you can expose an API front end, and then you could basically call that API end from Oracle Integration Cloud. And we'll talk about authentication and authorization a bit more as well. So how does this work? Well, the first thing you're going to do is create a container. And this is the best part, because you get to define the requirements. You get to define all of the dependencies that are required for your application, the code you're going to use, create that function and create that container image and push it to the image registry. Once the serverless function has been configured and basically pointed at the image URL, when you configure that and you trigger the function, it's going to pull the latest container image. That's going to instantiate the function, run the code, and provide, whatever response the code has been written to deliver. So we'll go through a demo here in a little bit, but it's very, very simple, very straightforward, and easy to use. In terms of improving microservices development and productivity, I've covered a couple of the tenets on this slide here, but really interesting and important to cover off on is the polyglot support. So functions, well, application development, as we probably all know, we likely have our favorite programming language, but sometimes for certain use cases, we may have to adjust and use a different programming language, or we may have different teams with different expertise that come together to build these serverless applications. And we need the flexibility to be able to write, certain applications in Java, other application components in Node or Ruby. And those are all supported within the OCI Functions ecosystem. From an automation or operations perspective, this is integrated with our DevOps platform. So we'll dig into that a little bit more in the next series. But this gives you the ability to easily and quickly integrate peripheral tasks by simply calling a function to, inspect a library or to move some data around, maybe capture and export logs to a SIM tool, but it simplifies the process. And because this is all integrated with identity and access management, you can define the level of access that your users have in terms of creating and triggering functions. You get to define what level of access the function itself has when it runs. So we'll look at the notion of allocating a resource principal to the function itself, giving it permissions to interact with other cloud services. So just one quick example kind of on the operations front here. In this instance, we have our CI/CD pipeline utilizing OCI DevOps. And that process, we have a producer that's pushing a message into a queue. The automation that's baked in is going to retrieve that message. This is the Cloud Event Service. And it's going to trigger a function that's going to go basically read the contents of that message that was put into queue, evaluate the output, potentially trigger additional automation depending upon what it finds. And then when it completes the processing activity, it will remove the message from the queue and simply continue to iterate as additional messages are pushed out to the queue. When you get the slides, this is actually a published reference architecture. So if you're interested in exploring, there's a URL in the slide that will allow you to go and deploy this very solution yourselves if you want to kick the tires a little bit. Question, can we use a Docker account or do we need the same account as in OCI? Our container registry is basically Docker Hub compliant. So you would utilize an OCI IAM user and you would generate an auth token. And that auth token is essentially your password to authenticate to the container registry. And that's going to give you access to push and pull those container images. So if you have a Docker Hub account, you would still have to create a set of credentials in OCI to communicate with the OCI container registry. All right. So with that, let's take a little bit of a closer look at the functions integration. I mentioned in the ecosystem, there's a number of services that can trigger functions. So we have the Cloud Event Service, which we'll take a quick look at. Notifications, service connectors, API gateway, which we're going to dig into in the second half of this presentation. And then, of course, Oracle Integration Cloud, CLI, SDK. All of these things can be configured to trigger a function. Again, when that function is triggered, it pulls the container image from the registry and then executes the code. That code can then be used to communicate with things like object storage, the OCI Vault service. A common use case in some cases, if you're running a fleet of servers as well, is you can have functions that turn servers on and off based on certain activities or events. You could have I've seen some customers use functions to go out and find servers that are not deployed or configured properly and simply eliminate them. So cleanup, make sure that we're not spending for resources we don't need to be using. And all of this, the logs, metrics, traces, it's sent out to the OCI monitoring service, where you can then funnel that into the log analytics service and have a nice graphical dashboard of what's happening in your environment. So the event service, touched on this briefly. This is essentially a service that automatically captures a wide variety of things that happen in your cloud account and presents the mechanism for you to react to those in the chosen fashion. So basically, launching a compute instance, dropping a file in an object storage bucket, all of these things will trigger an event, and then you can go and configure that event to trigger a function. And then that function, again, with your code that you've written, will be maybe evaluating the contents of a file written to object storage, or maybe it's extrapolating data from a log stream and then performing some sort of task or activity based on the content. So I'll just show really quick here, because this is a really we'll go to the event service. And we're going to create a rule. I'm not going to actually create one, but I do just want to show you what the conditions include. So either event or filter based on tag. And then if we use the event type, here's all the services that are supported that are automatically feeding these events into the Cloud Events service. So just as an example, we can go to compute, and anytime, let's say somebody somebody terminates a compute instance, I'm going to trigger an event. That event will launch a function, and my function would include code that would go maybe read the audit log to find out who it was that terminated that compute instance. In case we have a policy that says compute termination has to go through change management, I need to basically correlate any instance termination back to our change management log and ensure that everything was done following procedure. So really slick way. Once we define which event we want to respond to, we would go pick our function. Let's go here. I have my sample app, which we'll look into a little bit more later. And then that's it. We can create that rule, and now anytime someone terminates an instance, it would launch that function. All right, back to the slides. This is another example. So we looked at the event service, but this is a use case where maybe users or customers are uploading CSV files to an object storage bucket. Anytime that event occurs, it's going to trigger our function. That function is going to go read the contents of the CSV file, maybe do a little bit of transformation, and then load that into our backend database. So once this setup is implemented, I would basically give folks a pre-authenticated request to an object storage bucket, and they can use that to just upload their CSV files, maybe for reporting or daily sales statistics, and then it just automatically reads the content, writes it to the database, and we're done. So another nice way to be able to use functions to automate activities within our ecosystem. Another example here, the OCI notification service. So this gives us the ability to basically not only trigger functions, but also send notifications out to email, an HTTPS endpoint, or even notify people in Slack. So I could have an event that triggers like the the compute instance termination. That is going to fire a notification, and then in response, we'll have the OCI function go out and find out who did it. We'll maybe send a note to our Slack channel for change management saying, hey, there was an instance terminated. Those things all happen in parallel from a single occurrence, a single trigger of a particular notification. So the function itself, we're going to start by configuring an application. A single application is a collection of functions, and we define basically the network location inside one of our VCN subnets. So anytime a function triggers, it's basically going to be running inside of our virtual cloud network. So that gives us the ability to control access. It allows us to basically build a security perimeter around that network segment and control where, or what the function is going to have access to. The function itself, this is basically akin to a container image. So the function is going to have a container image location. We'll define memory, timeout, and additional environment variables that might be read into our code and our function at time of execution. And then last but not least, there is a command line interface for this. So it gives us the ability to quickly peruse our set of functions. We can build, package, deploy, delete, and there's also a set of templates that we can use to quickly launch a sample function if we're just kind of experimenting and wanting to kick the tires, so to speak. So this fn init is going to generate a boilerplate hello world function. There's a little bit more that goes into the command, but essentially you'll define the language, you'll define the application name, and then it generates a new function inside the application with some very basic code that you can go and experiment with. So let's see. There's a question about data transformation and mapping through the function. How do we get access to the CSV file? And Lynn was too quick. He shared a great link there. You want to take a look. But while we're here, let me just show you some sample code. So what I did is a basic function here. So we've imported a couple of libraries, including the functions development kit for Python. And in this case, we're going to be passing in the name of the object storage bucket. In this case, we're asking for the object name as well. But with cloud events, when you use the event service, the event message that is sent to functions will include the name of the object. It'll include details about the item that triggered the event. So you can simply read that out of the JSON in the message body. So we're going to take the bucket name, the object name, and we're going to try to go get it. If we get the object, if it's successful, we can then return the response and keep moving. Or if there's an issue, we're going to throw an error, of course, and we're going to exit. And then the actual function itself. So we have to specify our authentication. And in this instance, we're using a resource principal. So I've given functions. I've created an IAM dynamic group with a matching rule for the function in this particular compartment. And I've created an IAM policy that says this dynamic group has the ability to read objects in the compartment where the object storage bucket lives. So we're going to basically generate the client here with the resource principal signer. That allows us to authenticate and authorize to the object storage bucket. And then we're going to go read the contents. Again, in this case, I've defined a specific bucket and a specific object, and we're simply going to go open that object and read the contents. This is just a text file, but if you had a CSV, you would need to have logic in your code here that basically grabs the contents and then iterates through based on format or column types or column values, and then you would simply write a function in your code, but get Python, Ruby, Java, to organize that data in an appropriate fashion to go then insert into your database. So that's the really quick example there. Olivia is going to give us a little bit more detailed demo in just a minute, but I'll show you. If I invoke the function, you'll see here I'm just passing the name of the text file, the name of the bucket. And then when I invoke that, it's going to come back and say magical stuff. There it is. So the object was retrieved. The content is welcome to serverless functions on OCI. All right. Back to it. Just really quick. So the Docker account, if we go back into OCI, if you go to your user ID, so you're going to log into the OCI container registry with your user account. And then in your profile, you'll create an auth token. and that basically becomes your password. So the auth token, I would generate that token, give it a name, and it's going to give me like a 20-character hexadecimal value. So copy it, paste it, store it. Once you create the token and retrieve it, you cannot view the contents anymore. We don't store the user side of the token in anywhere. So important to keep that in mind. All right. So the FN CLI, once we are comfortable with the code we have, we can use the CLI to deploy. So basically, FN deploy is going to build the container image, push it to the container registry, and update the metadata for the function itself, which I talked about. And then it will update the function's metadata. So anytime we trigger that function henceforth, it's going to be leveraging the latest and greatest version of that container image. All right, as I mentioned, so when we configure the function, we're going to specify memory, timeout, any environment variables. So these are made available to the function at runtime, so you can read the environment variables to make decisions about what to do in your code. And there are some sort of boilerplate service limits around functions in your account. It's really important if you're going to be running, thousands or tens of thousands of concurrent functions, just make sure you double check the service limits so you don't overrun those. From an observability perspective, metrics, logs, traces, all of that stuff is automatically captured and available for any troubleshooting that might arise. And then we talked about these a little bit, so I want to keep moving here. Another example, and again, we are going to share the slides, and there's URLs, there's links in the slides to some of these reference architectures. But this is an example of where we've built a web front end for our users. This is what they're going to go and upload photos. Once they upload the photo, that is going to basically trigger our API gateway. It's going to do a get to our API gateway, which then triggers the function. And that function is going to call the AI vision service. That vision service is going to look at the contents of the picture. It's going to do data labeling. So is this a cat? Is this a dog? How certain are we? What percentage? It's going to store all that information and provide output back to the user so they can see, I uploaded a picture of a cat. We're 98% certain. And away we go. So I'm going to have Olivia jump into a demo. Let me just look at a couple of questions here. What are the parameters passed to OCI function through the event service? So the parameters, the data, it's going to be event specific. And if you take a look at the documentation, it'll typically have a sample message that the event service is passing to OCI functions. So you can use that to code your function and define what JSON elements to read and how to react to that content. If we need some changes to the existing code, can we update that? Or do we need to create a new function from there? I'm going to come back to that question. Olivia, do you want to take over screen sharing and show us your demo? And then I'll come back to that last question in the Q&A.
Sure. So I'll be walking you through a console of putting together object storage, functions, and the API gateway so that you can create a static website of content from object storage. So just kind of giving you an example here, and then I'll walk you through creating functions. So you can use functions to add business logic, so you don't have to worry about things like the complexity of running an app server, load balancers, or all the rest, since you're using fully managed servers. So the first step for this that I already went ahead and did was create an object storage bucket. And then from there, I uploaded an index.html file, so just a simple file right here. And then if I view the object details, I can see the information right here. So that's the first step because this is part of the process for this. And then from there, I went ahead and created my function. So in developer services, you'll see functions right here. I've already created an application, so you need to go ahead and do this. So give it a name And then you have to specify the VCN, the subnet, the shape. And one thing to notice about the shape right here, if you're using Cloud Shell, you have to make sure that the architecture or shape matches, or otherwise you might run into some issues there. So just one thing to maybe check if you're going to run through this. So that's the first step. I've already created an application. And then from there, I've already created these functions, but there's this getting started area right here. So you can do this in Cloud Shell, which is what I did here. But you also have the option to do a local setup as well, and it'll run you through some of these steps right here. So for Cloud Shell, I launched Cloud Shell right here. And once again, I already created my function, but you need to use the context for your region. So right here, I'm using Ashburn. Update the context with your functions compartment ID, registry, and then you need to log into the registry using the auth token as your password. So whatever you created. Eli kind of showed that a little bit earlier, but you would need that auth token. And then you can list your applications just to make sure that that application is there. And then from there, you need to deploy your function and invoke your function. So I already did that. And then you can go down here and you can see your functions that you have. So I have this Hello Python one that I've been using. And then if you wanted to see into your function right here, I could go ahead and click into that if I maybe want to modify something. You can click into that and you can see some of the information here. But yeah, so I've already made some modifications. So functions can be invoked in a number of ways. So I modified the code so that it checks to make sure that it has been invoked via an API gateway in response to an HTTP request. And if not, it's going to drop out and return a simple string. So this is going to allow us to safely test the function and see if it's working. So once you've set up your function, you run through these steps. Either, once again, you can do this in Cloud Shell or you can do this in a local setup. From there, I'm going to use an API gateway to expose the above function via HTTP. So go back to developer services right here. There's API management. I'm going to click into gateway, and I've already created one right here. So if you create one, you would give it a name, type public or private, compartment, so where you're creating that resource, and then you specify some networking, so your VCN, your subnet, and then you can go ahead and create your gateway. I already have one right here. And then once you've created your API gateway, you can go ahead and create a deployment right here. And a deployment just tells the API gateway what to do when it receives an HTTP request. And our deployment here is quite simple. So we want it to call our function for any HTTP request. And so I've already created one right here with a path prefix. We have our endpoint, it's deployed and everything. But you can go ahead and create a deployment, give it a name. So you can do this from scratch, or you can upload an existing deployment API, specify the path prefix. There's a few other request policies that you can set up. So you can do no authentication, single or multi. And then you can set up different routes. So in this case, I used functions and then I specify the function that I'm using. And then I went ahead and created it. And then lastly, I went ahead and tested my function. So right here, I did curl and I copied the endpoint from my deployment. And we can see that it prints out the details of that HTML file. And then here is also the Hello World site. One thing to note too, you need to update the security list for the API gateway to allow traffic from the internet to port 443 on your API gateway. So you might have to do that before this will work. But other than that, this is the steps that you'd run through for that. Great. And with that, I'll pass it back to you, Eli.
Awesome. Thanks, Olivia. That was really, really cool. There was a question about code changes, so let me just show that really quick. So basically, we can iterate, and if you do change the code, it simply you would want to redeploy, and that generates a new container image version. So if I go into my source code over here and just make a really simple change, something like success 2.0. And of course, code editor is going to auto save that for me, and I can come back here and I can redeploy. So we're going to deploy, and then the app is sample FN app. And what it's going to do is go in, it's going to build a new container image based on the code changes. So this is all baked into the FN CLI, which is why I prefer to use this, because it does a lot of the work for me. But of course, you can always create your own container images, push them to OCIR, and then simply configure the function with the appropriate path. So you can see here the container image, most of the layers already exist. We just had to make a few modifications because of the code change. And if we trigger that, there we go, success 2.0. So it's that easy, that quick, and our code change has been deployed into the environment. A couple more things just really quick before we jump back into the API gateway section. Go here. I just wanted to show some of the config options for the functions themselves. So you can see here, if we want to go into edit, this is where we could modify. If I had a sample image, maybe I wanted to try a different version, I wanted to roll back, maybe I deployed some code and 0.8 was no good, I could simply change that back to 0.7. I can change the amount of memory consumed up to 2 gigabytes, and then the timeout. So we can go up to 5 minutes. Typically, functions are designed to be quick, hundreds of milliseconds potentially. And if you're looking at running tasks that take 5 minutes or even longer, it might make better sense to deploy that out on Kubernetes. But you can kind of do some basic analysis to see where the cost performance is going to give you a better result. So how do we view and edit the existing code through the CLI? So typically the code is going to be stored in source control, and we would have cloned that corresponding repository, and to make the change, we're simply going to pull, do a git pull, grab the latest, or git fetch, grab the latest version of the code. We would edit that in our code editor. We would push that back to source control, and then with the local version, you can see here in my directory, I have the code itself for the function. I have the definition. I think Olivia showed this, and then my requirements, which would be any dependent the code is going to need to execute when we create. All right, let me get back. I know we have a few questions. I'll try to get to those at the end, but I want to get into API Gateway. So Olivia gave us a little bit of a preview here, and this is one of the ways that we can expose our functions to other applications, endpoints, and users. This is kind of outside of the cloud events, triggers, and Service Connector Hub and such. Whoa, that is a busy diagram. This is just to kind of showcase that there's different use cases, different scenarios, but the API gateway is essentially a network endpoint that is going to take an incoming RESTful request and pass it along to an appropriately configured backend. Now, for the sake of this conversation, we're focusing on functions, but if you have REST APIs maybe running on Kubernetes, on the container engine, if you have web servers running on virtual machines that will respond to an HTTPS request, you could also make those backend targets for your API gateway. We're going to dig a little bit deeper in here, but in this instance, we have the API gateway in a public subnet because it's accessible out to the internet. We can also do some things to sort of obfuscate that, like put a load balancer in front of it. We can put a web application firewall out in front of that API gateway, and we could leverage networking security practices to further harden our API infrastructure. So the API gateway itself, if we kind of peel back the layers of the onion again here, under the covers, we use basically a sharded approach where all of the requests, the configurations, the transactions are split across multiple resources. And we do this for performance, for scalability, and for resilience. That is so that if there's ever any sort of issue, in the environment, we typically have multiple copies, multiple shards available to handle those transactions. That way, if we happen to lose one, there's an issue, it's automatically resilient, durable, and highly available. As Olivia alluded to here as well, a single API gateway can have multiple deployments. So the actual web path that the applications are going to be requesting or that users might be navigating through, each one of those deployments can point to a different backend, whether that's functions or Kubernetes or some other service. Those can all be configured inside of a single API gateway that's typically designed at sort of the core application level. Generally, if you have a bunch of disparate applications in an ecosystem, you'd want to have a single API gateway at minimum for each individual app ecosystem. So you've got one for accounting and finance, one for e-commerce, one for HR tools. Generally, you're not going to have a single API gateway handling all of those. Just again, for security and accessibility reasons, it's best to kind of break those up. Now, if we dig a little bit deeper into the networking layer here, you're going to see we have an API gateway in a public subnet and an API gateway in a private subnet. And really the difference here is about accessibility. So we're going to have APIs that are exposed publicly to mobile web clients, end users accessing over the public internet. We'll need those in the public subnet for accessibility reasons. And we might have integrations to other backend systems like our ERP, our Fusion apps. And because of the integration on the Oracle Services Network, we can actually store that API gateway in a private subnet and then configure our network rules, our routing, our security list rules accordingly to allow access to and from that service network and those additional SaaS applications. And in addition to security lists, you can also apply network security groups to your API gateway endpoints. And the benefit of network security groups is a bit of a more fine-grained control. With security lists, you're defining ingress allowed ports. You can come in on port 443 and access resources in the subnet. With network security groups, they can reference one another. So if I have a collection of functions or Kubernetes resources that are utilizing their own network security group, I can simply reference from that network security group the NSG that's tied to the API gateway and say that NSG can access resources in this NSG via port 443 or the corresponding port. So a little bit more fine-grained network access control. A couple of use cases here. We've kind of talked about the internet facing, goes into public subnet, accessible across the internet. Maybe we're going to use a WAF for extra security there. And we'll look at auth a little bit more, but in this case, using something like OAuth or JSON Web Tokens to authenticate. Cloud to ground. So if we have on-prem, and this is kind of like the first image we looked at where we're connecting over maybe Fast Connect or a VPN from on-premises, we can access that API gateway both locally and across the public internet. In a hybrid case, we maybe have resources in a private subnet that are accessible both from on-prem and from the API gateway. And then users on the internet would still have to go through the API gateway in order to interact with those backend services. And finally, private cloud. We may have a situation where we're simply running on-prem applications. We need to interact with our cloud-based resources, but they're not accessible to end users out on the public internet. So we can secure that connectivity over either VPN or Fast Connect. All of our resources exist in private subnets because we're going to be using private routes. And this might be a situation where we're doing a data center migration, or we're extending on-prem to cloud in a more of a sort of a hybrid use case. But any of these things are reasonable approaches. Another thing here, so from an access control perspective, of course, with IAM, you can define who's allowed to do what with your API gateway and functions services. But IAM also has the ability to bind user roles that allow from an API request, from an authentication perspective to the API endpoint, you can also define certain levels of access. And we'll take a look at a couple of the authorization policies. So in this particular situation here, we're going to be using just basic API authorization. This might be Oracle's Identity Cloud Service, Active Directory, or an SSO tool like Okta. We're going to pass the authentication out to the auth provider. The auth provider is going to basically pass a token back to the client, which they will forward to the API gateway. Once API gateway is able to authorize or validate that the token is good, we have roles defined that authorize that user to perform various tasks. Dynamic authentications, we might have multiple identity providers based on different tendencies, different customers, different business segments. So the API gateway can be configured to leverage multiple identity providers in this case. And again, the various clients, as they connect, they're going to be routed to their own identity provider, where they'll get that token, they'll pass it back, and we'll check to make sure that they've been authorized. Request-based. So we can take into account the route, the tokens, the header, the subdomain. This typically uses something like JSON Web Tokens, JWT, and it's designed around OAuth 2.0 standards. So this might be a situation where user A has access to /pets, /groceries, /travel, if you will, and then user B might only have access to /pets. We've been able to define basically at the user or the role level what backend resources they're able to access. And last but certainly not least, OpenID Connect. So this allows us, again, to leverage third-party authentication or identity providers. And that takes care of all the authentication of the resource. Again, we leverage that token to authenticate back to the API gateway. And then if successful, we can route to the corresponding API paths that we've configured in that API gateway. So that is a lot to digest, I know. Let me just, while we're here, show a couple quick things on the API gateway front. Something that I didn't cover in the slides, but is of interest to many folks. So I'll just show the usage plans really quick, and it does require configuration at the API level as well. But usage plans give you the ability to potentially monetize your APIs. If you're providing a public service, or you're providing a resource to the general public, and you want to kind of control performance and throttle access, you can create usage plans, you can create entitlements that basically allow for different levels of performance. So I might come in here and say, gold, this is going to cost $9.95 a month. And if you pay that, you get 100 requests per second. Oops. And 1,000 per day. We're going to add the deployment. So the cloud coaching sample, this is where it's going to tell me I have to have the usage plan configured, and the request policies. But now I could add multiple entitlements here. They basically say, this is where the correct authentication schema comes into play as well, where based on the auth type, based on the header, the request source, I get to define whether you have the gold standard or the platinum standard or whatnot, or the free tier, which is maybe 1 request per second and 100 per day. That's just making it available to all of our potential future customers, if you will. All right. So with that, hopefully that was of interest. A lot of great questions. So thank you to all who interacted in the Q&A today. A lot of really good stuff. And hopefully there's some interest and excitement around serverless applications. I'd encourage everyone to dive in, go play with OCI Functions, give it a try, see how it works. Jump into the API gateway and explore some of the possibilities there. And above all, have fun and enjoy. We did ask earlier if there's any other topics you'd like to see. We're putting together some future series, some future sessions. So let us know in the chat if there's other content you'd like to see, and we will get to work on that. We do have a public Slack channel. We'd love to hear from everybody. You can click the QR code there, come out, join us, say hello, ask questions. Drop into our developer hub at developer.oracle.com there. A lot of great content, tutorials, workshops, fun material. And then, of course, free trial and a link there to future upcoming events. So with that, I'm going to pass it back to Renu. Please take it away.
Thank you so much, Eli. And thanks, Olivia, for the great session and the demonstrations that you gave us today. I hope everyone enjoyed it and learned something new today. Our next webinar and the last one in the series is Build or Enhance Your CI/CD Architecture with OCI DevOps. Please do not forget to register and join us same time on Monday, May 6th, if you want to explore the core capabilities of OCI DevOps, see how to integrate with tools you may already be using, and review different deployment strategies. We will be adding additional series soon, so I recommend that you bookmark the Day One and Beyond page and check frequently for new sessions on trending topics. With that, thanks again for joining us. See you all next time. Have a great day, everyone.
Thanks, everyone. Take care.